Lecture number 33 as well as 34, and today's attendance I would also mark for Friday's class, right? And today let us solve CAT 2 problems. So let us look at the first problem. There are two questions for each module. So 1A, 1B. So there are students of the class have solved this problem, and alternatively other segment of the students have solved this. So first problem from module 2, where you have solved the problems of frames, right? And the second module, friction problems. So we had this problem as well as a ladder problem, and then the third question that you could have answered is on area moment of inertia, section properties. So these are the 6 problems that I'm going to solve now. You can see that you have solved in the similar way in the examination, right? So look at that here. This problem, determine the component of all forces acting on member A, B, C, D of assembly shown. So what is this assembly basically? This assembly is forming a frame. Why it is a frame? Because there are members which are multi-force member in this. For example, you look at ACE. You have an external force 1000 Newton acting at point E. Apart from that, you also have this support at point A, pin support, and at point C also a roller support. So you would have here AX, AY components reaction, and you will have CY component reaction, right? So that is why it is a multi-force member. So you look at again a member which is of our interest in this problem is ABCD. So ABCD. So in that we have how many unknowns? There are 2 components of unknown at A, 2 components of unknown at B, and there is single component CY unknown and DY unknown magnitude. So these all what is the understanding of this frame. And what is this frame? Is it a rigid frame or a non-rigid frame? If I remove the support at C, this entire configuration would collapse, right? So this is a non-rigid frame. And if you look at how many unknowns are there, if I do not collapse at B, there is a simple support. So it's a hinge support. At D, there is a roller support if I do not remove C. So entire frame, I could solve for an unknown Bx, By and Dy without dismembering them. So this is statically determinate frame. So that is how you could classify the frame class, right? So what is that? This frame is of class statically determinate non-rigid frame. Non-rigid, statically determinate frame. So now what is asked is determine all force components in the member A, B, C, D. So let me draw a free body diagram of A, B, C, D separately. So if this is a schematic representation of A, this point is B, there's a point C here, and there's a point D here. And this is extended. So this is D, this is C, and this is B, and this point is A. Now, what are the unknowns here? The unknowns are here By and Bx. And at point C, I do not, okay, at point C there is contact, a roller contact. So I would have here again a reaction, right? So that may be considered as, say, I do not know here the direction, whether it's upward or downward. So I have this vertical force. Let me consider that acts downward in this case. In case it is not correct, then accordingly my sign will change. So Cy. and I will have here dy. So the question of our interest, all the forces what are acting at point A, I would have, again it's a pin, so I would have ax and ay. So now how many unknowns are there? 1, 2, 3, 4, 5, 6 unknowns are there. And I cannot just solve these all 6 unknowns just from using 3 conditions of equilibrium. That's what is known, right? So this height is 40 here, 40 mm. This distance is 80. And this distance from here to C is 80. And this remaining 40 here. So so this 1000 Newton will not come in this because that is acting in the link AJCE. So this 1000 Newton will not come here. So in such cases, what I should do? I should first look at, since it is statically determinate problem, I can find out by drawing entire frame free body diagram and 3 unknowns without dismembering. So that is here at B and D. So what does be my free body diagram? If I take the same configuration and if I put here a free body diagram, say this is my By and this is Bx, because it's a hinge, and I have here dy. So rest all I will not show because I do not dismember this. So at A I don't require to show the component. I do not take out this roller. So I do not require to show Cy. So I have only 3 unknowns in this free body diagram. So I can very well find out now these 3 unknowns. So I will solve first for this Bx, By and dy. So how do I solve that? By observation itself. It is clear that if I apply first equation sigma fx equals 0, I have now Bx plus 1000 Newton equals 0. That solves Bx is 1000 Newton to the left because it's minus 1000 Newton. So you would have this direction. So what is that I get? Bx is minus 1000. So what is the meaning of minus 1000? Bx is acting towards left. Whatever is considered here, it is just opposite to that. Is what I should put. Then I can take moment about point C at point B and equating to 0, I would be able to get what is dy. Because Bx, By will not participate in the equation, I would get dy into what is the distance of D from point B? 80 plus 40, so 120 mm. And the moment is about point B is counterclockwise moment. That is why this is positive sign, as we follow the convention. Counterclockwise moment sum is equal to 0. Right? All this counterclockwise moment is positive taken. So dy into 120, and what is the other force is 1000 Newton. So that would create at point B a clockwise moment. So minus 1000 into this height from B is what is 80. So that's equal to 0. So by solving for dy, I would get this is 1000 into 80 by 120. So what would be my answer? It is 6.67 Newton. Since it is positive, my dy direction is correct. I would take that upward, acting upward. So now I have got in this Bx, By and dy. And now I will look at this free body diagram of my interest of what is asked in the exam. So this Bx is as it is here, and I have got here 1000 Newton to the left. So I can either change this direction, what is considered in this diagram, or I can put Bx value here of my obtained value minus 1000, holding the same direction, 1000 Newton Bx. And what is my By? It's upward, so it is 666.7 Newton. And dy, sorry, dy is this, right? Dy to be found out. Dy is what we have got, 666.67 Newton, and By is unknown, Cy is unknown, here Ax, Ay unknown. So now what I should do, I can also get what is my By from this diagram. So that is known. So from entire frame free body diagram, applying third equation. So this is my first equation, this is my second equation I applied. Third equation is sigma Fy equals 0, considering upward forces positive. I would have now dy. So dy is 666.67 Newton plus By, and there is no vertical force other than these two. So this sum is equal to 0, and By is now By. Right, sleeping. By is minus 666.67 Newton, and you should have the direction to be reversed. So when I consider By upward, and if I get positive value, then consideration is correct. Since I get negative value, my By direction is downward. So I don't change here. Instead, I'll put here minus 666.7, 666.67 Newton as it is. So now you see the link ABCD of this frame has got only 3 unknowns. Out of 6 unknowns, 3 are found out from the entire frame free body diagram, and the remaining 3 I can find. The remaining 3 are Cy, Ax, and Ay. So how can I find out that? I can take moment about point A and find out what is Cy. So now coming to this free body diagram. So FBD of AB, CD, I would take moment about point A equating to 0, and I can solve for Cy. So here Cy direction considered is acting down. So Cy into this distance to create at point A clockwise moment. So minus Cy into the distance is 160 mm. Right, and Bx is now let me look at whatever the direction of arrow. So Bx at point A as per this direction creates counterclockwise, but this minus value, so minus 1000 into 40, that is moment due to Bx, and moment due to By is upward, again creates counterclockwise, but the magnitude here we have got is minus, so minus 666.67 into 80, and then dy would create about point A counterclockwise moment, so plus 666.67 into this distance is 200, equating to 0. So this will solve for what is Cy. So Cy into this minus, if I take it on the other side, so I will have Cy would be minus 1000 into 40 minus 666.67 into 80 plus 666.67 into 200 divided by 160 Newton. So if I work out for this, what is that I will get? I will get my Cy value, and that would be 250 Newton. I get 250 Newton. I get 250 Newton. Right, and since it is a positive value, the direction considered is correct. Cy acts downwards. So that's my Cy. So here Cy is 250 Newton. Now I have to get my Ay and Ax. So what I should do? Look at here by applying other two condition of equilibrium. It's a very straightforward problem. So sigma Fx equals 0. I would get here what are the horizontal forces in this? One is this Bx, another one is this Ax. So with respect to the direction here, Ax to the right and Bx to the right with this minus sign. So I would have now here Ax minus 6.67 equals 0. That solves for Ax equals 666.67 Newton, and the direction considered is correct to the right. So this is the Ax. right? That's AX. And now to get AY, I have to use the third equation, that is sigma Fy equal 0. Sigma Fy equals 0. So when I apply sigma Fy equals 0, I would get By plus dy plus Ay equals 0. So this solves for Ay. So By is minus, dy is plus. So okay, this is also there, minus Cy. So minus Cy equals 0. So I would get, right? Let me put it properly. Minus Cy equals 0. So this is minus 666.67 plus 666.67 plus Ay minus 250, that's equal to 0. Therefore Ay equals 250 Newton and direction upward here. So this solves for our problem. So now what is your final answer? Your final answer here is, if this is my member, this point is A. At point A, I have Ax to the right. So I will have here a component Ax. What we have got, Ax is 1000 Newton. Right? So how do you get Ax? Ax is 1000 Newton. Bx is 1000 Newton, right? Bx is 1000 Newton we have got here. It is Bx. Bx is 1000 Newton. So when I substitute that in this equation, Ax minus 1000 here. Ax. It's not this. Minus 1000. So this is 1000 Newton. Right? So please correct this. This is 1000 Newton. So Ax 1000 Newton and Ay upward, the value of that is 250 Newton. 250 Newton. And at point B, I have Bx. Bx, what was obtained is, now let me put the correct one. Bx negative value, so to the left it is. So I had Bx value in this direction. This is my Bx. And By value, you had negative value, that means it is downward. So this is Bx and By in this direction. This is By. So By value you had 666.67 Newton, and Bx value you had what is Bx value you have 1000 Newton. 1000 Newton, and at point C you have Cy acting down with the value of 250 Newton, and at point D, that's here, you had dy with the value of 666.67 Newton. So this is that answer what is asked. So you should solve like this problem, right? So if you have drawn your free body diagram correctly, you would get 4 marks. So free body diagram of entire frame 2 marks, free body diagram of ABCD alone drawn 2 marks, 4 marks, and then determining the 6 values would get 6 marks each. So that is how I would provide marks for your solution. So now